Good morning, this is David Johnson, and today I would like to discuss laminate allowable properties. We had one tutorial on laminate, which is apply-by-apply analysis. This is going to be laminate. Now, back in the old days, when I worked at Bell, we used to do laminate analysis, which I think was the right way to go. So what I've done here is open up the material properties. This is one of the Collier properties. They don't really have a full property allowables list. Oh, there we go. I'm trying to find it. They don't really have a full set of allowables, but it's good enough just to discuss the topic. So the question comes is, why would I want to do laminate analysis instead of laminate? And I don't have all the answers, but just from the best of my memory is, I think personally laminate analysis is kind of a farce and just a very theoretical solution to a problem that's not appropriate, because laminate analysis works very well if we have no damage. But once we incorporate damage, impact damage, and open hole allowables, calculating allowables on a apply-by-apply basis just seems to be not appropriate. So some corporations use laminate analysis and they use laminate allowables, and they make their models a little bit differently. So before we start with this, let's just quickly go into the model. What would be the difference if we use laminate allowables instead of laminate? Now, laminate allowable means I have an allowable for the full laminate. I just look at the whole laminate and I write one margin. When I do laminate analysis, I look at every layer. I could have 50 layers. I calculate strains in every layer in different directions, 0, 45, and 90, and I calculate the minimum margin. So I have a minimum margin in a particular layer. Since composites is an ultimate analysis, I don't care. All I want to know is, when does the laminate fail? And so what happens is, if I perhaps find one of these graphs, a good one, perhaps this, you can see here this is usually a design driver, a compressive allowable after impact, CAI. This is kind of similar to BVID. And what we see is a curve. We have a laminate with 0% 45s and 100% 45s. Normally our design space, Collier has shown a graph all the way, but normally we wouldn't have this. Our design space might go to 90% and might go to 10%. So we'd cut it off here. We deliberately cut it off because we don't want people trying to make laminates outside of our allowables. So what we probably do, let's say a compression test, we may test 3 or 4 laminates. For instance, we could test 20%, 40%, 60%, and 80% at a particular thickness and a particular temperature. And as you can see here from Collier, we plot the points and we just interpolate along this curve to get our allowable strain. Now, for those not initiated with composites, it looks kind of strange because it says, well, if I have more 45s, I've got a higher allowable strain. But the stiffness is much higher for this 20% of 45s, and so the actual load carrying capability is much higher for this 20% than it is for 80%. So one must be very careful when looking at strain allowables and allowable loads. So that's kind of the basics. Now, one of the advantages of using laminate analysis is that when I do my apply-by-apply analysis, I have to create all the layers in my model. And it's quite a lot of work, and it's quite time consuming, especially when I keep changing the layups as I do go through the optimization. The nice thing about laminate analysis is my model is much easier to make. I simply create an orthotropic element with a stiffness in direction X and a stiffness in direction Y and a shear stiffness, and it represents the whole laminate. And so I don't have to model all these layers. And when I recover the load, I only recover the load in the X, the load in the Y, and the shear. and I go off and do my analysis and compare my allowables to what's in here. So the whole process is simpler from a perspective of making the model, recovering the loads. There's a lot less data, loads of data, and in my mind, and people may disagree because there's a few quirks, but I think the allowables process is a lot more straightforward too. Because if you notice, these allowables already include impact damage and open hole. So right off the bat, these are the allowables that I use. There's no pristine allowables with corrections, at least for the primary laminate. And so if you look, Collier's only put one temperature in here. You'd have allowables for all the different temperatures. But if you look through the list of what we have here, we have compression, CAI, compression after impact, open hole compression, filled hole compression, and BBID. This is to accommodate most corporations and how they do things. Not all companies use all of these graphs. And then we have a strain for pristine. We have tension after impact, open hole tension, and filled hole tension. You can see Collier has not filled all these out. And we also have the strain, shear strain, allowables, and the bearing. And notice that the shear strain allowables are quite high, but that's because there's a very low stiffness, because a lot of 45s. Now we can create these graphs using percentages of zeros, percent 45s, percent 45 fibers, or the old Lockheed Boeing method was AML. This goes back a long time, and we enter our allowables. As you can see already, we've only got one form here, whereas the laminate allowables we had a whole bunch of forms. And then Collier's included these corrections. And notice, so I'm not going to go over these again because I went over these in the laminate analysis. If you want a review of this, go to my laminate analysis training session. But what you'll notice is there's no laminate correction, because we're already working with laminates, and there's no BBID correction because the allowable curves already include BBID. So what Collier's done is just given a place for, if that's for allowables, of course for stiffness there is a correction. So what Collier's done again is they've said here's my uncorrected values, so all this column here, and they say apply these corrections, and these are the allowables, stiffness and allowable stresses and strains that are used to calculate the margins of safety. We can plot some curves up here, but again I can't plot this because we've only got one temperature allowable plotted, so I can't plot this curve. And just very quickly I'll just go over the main, probably the most important correction here could be a co-cured correction. Some people may use some of these others, but it's going to be not fairly rare. So, in summary, I haven't used laminate analysis for over a decade. The companies I've worked at in the last 10 years have all used laminate, and it's quite some time since I did laminate analysis, but I suspect, from my perspective, from a practical and just from a process perspective, this is by far the easiest method. What has to be traded off is the cost of the test plan for laminate analysis versus laminate, and much depends how you go about it. But from a stress engineer perspective, if I just ignore how much the test costs, I would much prefer to use a laminate analysis methodology for my modeling loads and for my stress analysis. So I'm going to say thank you very much. A very short tuition there, just give you a bit of a heads up. There's a few of my preferences. Some people may disagree, but that's okay. Thanks very much and have a good day.